Hi everyone, my name is Catherine Rescatus, and this is my final project for Ocean 411. The title of my project is Moby Data. So for a little bit of context, this is a continuation of some of the research that I got to be involved in over this last summer. This was part of the University of Washington's Visions 2024 oceanography expedition, where I got to work and live aboard the RV Atlantis, the research vehicle the Atlantis, which you can see in this image here. And during this project, I got to be involved with a lot of wet lab techniques and doing different data collection tasks aboard the ship. Now I'm enrolled in 411, where I'm getting to continue doing some of that research, but off of the ship. So I am a computer science major, so what I wanted to do with this project is look at different computational modeling techniques and see how can I apply them to oceanography and marine biology. And this leads to my project, Moby Data. And so one of the things that I want to do with this application is make it a tool for different scientists in order to get instant insights and a smarter hydrophone analysis based off of different data you could collect on an expedition like the one I was just on. So if you're not familiar with what hydrophones are, they are instruments for listening to sound transmitted through water. So they're very similar to a microphone, but instead of air, we work with water. In terms of the engineering, it's a little bit different than how microphones work as well, if you're curious. So since we're looking at water pressure, they use different ceramic plates in order to detect these different changes in pressure, as opposed to moving coils that exist in microphones that work with air pressure. And so what I wanted to do is once we have all these hydrophone recordings on expeditions like Visions, they're all compiled together in the OOI database. And I wanted to improve easy access to getting that audio and also allow users to upload their own audio if they have it. And there's a bunch of different features that Moby Data offers. First, if you could tell by the name Moby Data, I wanted to look at different whale call detections. So I've hard-coded a bunch of different parameters that can be used in order to tell if a whale call is in a clip of audio. You can also input your own parameters if there's a specific whale that I did not look at that you're interested in. Additionally, I looked at different clustering to similar recordings, so you could see how recordings might be similar to other recordings at other points in time, and also looking at different data compression and reconstruction methods. And then before we dive into the demo, I wanted to show a bit of the tech stack. There's a lot of different icons on the screen, but the ones on the right are Flask, HTML, JavaScript, and CSS, which are mostly just for like actually creating the app and seeing all the pretty formatting things. But all the other icons have to do with the actual tech stack for working with these different audio data and doing some of the cool analysis that I did. Okay, so if you want to run this on your own machine, instead of just looking at this demo, these are some tips for reproducibility. You need to have Python and MicroMamba or Anaconda installed on your computer. And then you just need to clone the repository, which is linked here. And I would advise creating a Moby Data environment with Conda before you start running and installing things. And you can install all of the necessary libraries by running this command. Now that you have everything set up, you just need to navigate to the Flask app folder by running this command, and you can finally run the application just by hitting python app.py. And then you can just click on the link that shows up, and it'll be running on your computer. Okay, now let's dive into how it works. Okay, so we're gonna go ahead and run this application. And I'm gonna do that by running this command, and then we'll open up the app and take a look around. So you can see it's opening a new tab, and it'll first bring us to the home page where you can look at different information on how to use Moby Data and also just about the project in general. And then if we go to the upload page, you can select from your file explorer if you have some audio that's downloaded and go ahead and upload it. It will take a second to load just because there's so much data and so many like different insights I'm extracting from it to generate a whole bunch of figures, so it takes a bit of time. So in the meantime, I will quickly mention this accepts both the .wav and .mc files. mseed is actually meant for seismology data, but it is the default file format for the OOI database, so I had to make sure I can work with both different modalities. Yeah, and so you can see we have a bunch of figures that are automatically generated. So this can give scientists good insights if they're wanting to look at different spectrograms and maybe if they're trying to identify certain patterns or if something interesting is going on. This particular file that I randomly selected, it doesn't look super crazy, but you can get a general feel for what is actually going on in this audio file. Okay. The other thing I did was looking at different clustering, so checking how similar different recordings are. This is with a very small sample size, so I would take this with a grain of salt. But using this K nearest neighbor, you can look it up, algorithm, I can put these into different lumps. And you can see these purple ones are all together, these yellow ones are another cluster, etc. And then looking at how different they are. So this looks like very interesting. The other thing that you can do is looking at whale ID. So as I mentioned, again, this clip I'm using is not super interesting. So we didn't detect any of these different whales here. But if there was, say, a different type of whale that you wanted to look at, you can define it using these different values here. So how fast is a click? What is the frequency range? And how intense should it be? This is based off of decibels. And so I'll run it here. And this should, if it works, since this is like very short duration, very wide range frequency, we should get a check mark. So you can play around with this and see how you can detect different whales based off these parameters. So that is the basis for this. You can also work with Explore. So this will do the same thing as upload, so I won't actually wait for it to run again, but you can select a day where there was a recording and select a time using this GUI. And then if you click submit, you'll get the same thing that you saw with upload. But yeah, that is the basis for Moby data. Currently in progress is looking at this different reconstruction and compression algorithms that we can use for working with this audio data. You can currently run it using scripts on the repository. So if you want to check that out, you can, but there isn't as nice of a GUI to do that. So that will be something I want to do for future work and future iterations on this project.